What is a vector? So a vector is a directed object. A vector is a directed object that has two properties: magnitude which means length, and also how big something is or vector is. So the second one is direction, which means which way it points. Which way it points. So if we have one example, walking 5 meters north. In this example, the 5 meters is our magnitude. And the north is our direction. So together this is a vector. Why? Because it has magnitude and also it has direction. If anything has this two property, so we call them vector. Position of a vector. Vectors don't depend on where they start. So we can start a vector from anywhere that we want. For example, from here we can draw a vector like this, or we can draw like this from this place. So from any place we can start a vector. But in coordinate geometry, we usually assume the vector starts at the origin 0, 0. For example, if we start a vector in coordinate geometry, it means if we have x-axis and y-axis, in here if we have vector A, this is vector A. In here we usually assume that this vector A starts at the origin, which is 0, 0. This point is x is 0 and also y is 0. For example, if you have a vector v, which the coordinate is 3 and 4. So in here we can say that this vector, if we have x-axis and also y-axis, this vector v, which is 3 in x-axis and 4 unit in y-axis. So our vector v is, we can draw like this, that if this is a vector v, the coordinates are 3 and 4, but the origin of this vector is 0, 0. Vector addition. Vector addition. So, if we have two vectors, we can add them geometrically, and also algebraically. So let's explain how we add vectors geometrically first. For example, if you have two vectors, vector x and vector y, if we want to add these two vectors, how are we gonna add geometrically? So first of all, we're gonna draw vector x, and then we draw vector y, tail to tail, like this. And then we continue from the vector x along the y, vector y, like this, parallel to vector y. And also we continue from vector y parallel to vector x, like this. And then we draw a diagonal line. So this line is actually our vector x and vector y addition. How are we gonna add two vectors algebraically? So if you have two vectors, for example, if you have vector x, which is equal to 1 and 2, and we have vector y, which is equal to 3 and 4, then what is x plus y? Vector x plus vector y. So our vector x is 1 and 2, plus our vector y is 3 and 4. So, and vector x plus vector y is equal to. So we add x coordinate with x coordinate. So it means 1 plus 3 and 2 plus 4. Y coordinate with y coordinate. 2 plus 4. Then x plus y is equal to 1 plus 3 is 4 and 2 plus 4 is 6. So finally our answer is this. The next topic is scalar multiplication. Multiplication of vectors. So we can multiply a vector by a real number or scalar. So it stretch or shrink the vector. If the scalar is negative, it also reverse the direction. So if we have a vector, for example, if we have a vector x, example, if we have a vector x that it is 2 and 3, 2 and 3, and if we have a scalar t, which is 2, what's gonna happen here? What is x times t here? So x times t is, or x is 2 and 3 times our t is 2. If we multiply these two with each other, it becomes 2 times 2 is 4, 2 times 2, and 3 times 2. So finally, x times t is equal to 2 times 2 is 4, and 3 times 2x, 6. So this is our x times t. So see here, it stretches the vector x here. In here, the vector x stretches. But sometimes if t is negative, the vector x change its direction. For example, if we have x which is equal to 2 and 3, and t equal to minus 2. If we find tx, if we want to find tx, what's gonna happen? Minus 2, t is minus 2 times vector x, which is 2 and 3. So t times vector x, so minus 2 times 2 is equal to minus 4. And minus 2 times 3 is minus 6. In this example, the vector change, this negative 2, change the vector direction.